Okay, so this is our presentation for Project 2 in Design Machine Elements. My name is Kevin, and my group partner was Eric, and we designed a pill bottle that is tamper evident. Yeah, so we designed and prototyped a tamper evident pill bottle, and we considered how it's gonna fail, uh, and we wanted to make sure that the bottle has a clear indication that it has been opened before. And we also considered that uh, how we were going to make it. So the practical implementation of it. Just, yeah.
The
Okay.
one before?
Yeah, this is the one before. Oh, sorry.
Yes,
Okay.
that's okay. All right, the design requirements. The bottle and cap design must give a clear indication that the bottle has previously been opened, uh, fail in a non-hazardous manner, being reusable, meaning that the bottle should be easy to reuse in other purposes, be sealed without prematurely damaging the temper evidence seal, and easy to open. In that way, the final user um, must be able to open the bottle without any external tool.
Yeah, so the for our engineering considerations, we we wanted the uh, the bracket to fail in a brittle manner. So it would we didn't want it to be ductile and have it deform before breaking. We just wanted it a fast and clean break. So brittle materials and brittle failure would achieve that. Um, and we considered how it was going to break. And we figured out that having it fail by twisting would be easier for the user to open the bottle. Uh, and it's also uh, prevents a lot of like minor forces that could be exerted on the bracket, and it won't those forces won't necessarily break it prematurely. And we use stress concentrations to figure out where the break would happen. So just to isolate it, basically. And we considered how we were going to manufacture it. And so for prototyping, we chose 3D printing just to be able to correct the designs and just go through prototypes really fast. And later we'll probably use blow molding for mass production.
The proposed design concept, we decided to prototype a portion of the bottle, which is the body with the thread and the cap. The cap is made of a ratchet wheel, and the body has attached bracket. The idea is the cap is gonna turn and it's gonna activate the bracket, twisting it until it breaks, as my partner says before. That's our proposal design, as you can see in the picture. And the main concept is the ratchet with a L shape. Um, yep.
Yeah, this is the engineering drawing. Um, but yeah, the cap is essentially a gear. Um, and there's a little bracket connected that has the word safe on it. So when that breaks, um, it'll it'll indicate that it's has been opened before. And right here, that's where the bracket connects to the bottle, and that the connection between the little connector to the bottle and the bracket is where the failure will occur because it's a smaller section. It tapers off a little bit, so just to make sure it breaks off cleanly. Yeah. And the
Oh,
prototype, oh,
okay. Yeah. Go ahead.
the prototyping for the prototyping plan, we first wanted to just figure out what material we're going to use. And initially, we're just going to use draft resin for 3D modeling and printing. But then later we'll use just regular plastics that would be used for pill bottles. So probably polypropylene for the bottle because it's lightweight and it's chemical resistant, and polyethylene for the can because most stuff is really made out of that. It's cheap, and acrylic for the bracket uh, for the L-shaped bracket and the little connector to the base, because because acrylics are brittle, so it'll just make sure that we get the break that we want. Um, so after we figure out the material, we go into the CAD modeling, uh, and just design it initially, and then to make little changes, uh, and then yeah, print it. We'll uh, create the prototype by 3D printing and then by blow molding after. Uh, yeah, the assembly is just putting it together and then putting the cap on basically, and then not making sure that the bracket doesn't break when we're putting the cap on. And then we got, yeah, testing is essentially the same thing. Just make sure that the bracket doesn't break beforehand. And then after we tested it, make sure it feels nice. We refine it. We're just gonna refine the design. And the thing I could see right now in the close future is making the teeth smaller so that the cap isn't as hard to open. Um, or it could be just smoother in general because right now it's pretty hard to. Um, it feels hard to open because of the teeth. Yeah, and then after the refinement process, the final prototype will be delivered. Yeah.
And testing and evaluation. Once we proved the prototype by closing the bottle, simulating the closing with the bottle with the gear cap, we we made the we closed the bottle, and then every time the cap makes a turn, it put it away the bracket without breaking it. That's how we get to the end of the cap, sealing the bottle. But once we proved that it went all the way down to the bottle, we start testing the bracket failure, which was which happened when we tried to open the bottle because of the force exerted over the bracket by the cap. When the bracket was off of the body, it left a small notch that is visible, and all the brackets, the three brackets, uh, fell from the body, which is an improvement we will have to work on for future prototypes.
Yeah. Okay. Yeah. So there's for the timeline for this project, thinking it's going to take a month, because we initially this first week was designing and putting in the research for the design, and the second week we're probably just going to make the gear smaller to make the cap smoother and just have it to be easier opening process and have it feel nice in your hand. Um, and after that, we'll probably move on to making the uh, like getting closer to the final product. So we wouldn't necessarily 3D print anymore. We'd start using the plastics for mass production. Um, and yeah, week four after um, making the standard plastic stuff. Um, we'd deliver the final prototype after that. And at each week there would be CAD models and a physical prototype that would be delivered.
Okay. Conclusion and future steps. Yeah, successfully the device accomplished its goal of sealing the bottle, and when opening, breaking the bracket, it was visible, noticeable that the bracket fell, and then that was an improvement that we have to do for the future prototypes. Also, the cap itself can be refined by making the teeth softer. At this moment, it's rough, but that's another improvement that we can make. And yeah, I think that's all.
Yeah, I would just say that the bracket can fail in a way that it stays on the bottle as opposed to having it just fly away. Because right now it breaks off and it'll fall down to the ground. Um, Maybe the user doesn't want to pick it up or can't pick it up from the ground. So having it stay a little bit on the bottle might be easier for cleanup. Yeah. All right. Thank you.
Thank you. All right. I think